So let's continue with network fundamentals, and we will look at simplified PERT network. Yes, so in this case, when you're working with a small project, you might have such PERT network or PERT chart where you can see various activities. And by looking at the legend of the diagram, you can see different events. Yes, starting with a contract and finishing with a startup activity. And as you can see from this chart, there are activities with various durations. And by looking at this chart, you can identify the critical path, yes, which is starting from activity 1, 2, 3, 5, 6, 7, 8, and 9. And there are various alternatives, but the critical path is the longest path. Yes, so, and you cannot delay any activities on the critical path, because if you do that, then you need to make some changes. Yes, think how to be back on track and make some changes so that you will finish the project according to your plans. So we looked at PERT technique. Now let's look at the graphical evaluation and review technique, or GERT. So graphical evaluation and review techniques are similar, but have the distinct advantages of allowing for looping, branching, and multiple project end results. So it adds more complexity. So with PERT, one cannot easily show that if a test fails, we may have to repeat the test several times. And with PERT, we cannot show that based upon the results of a test, we can select one of several different branches to continue the project. And these problems can be overcome by using GERT. So now let's talk about the dependencies. And when we are talking about dependencies, there are three main types of dependencies, which are mandatory dependencies. Yes, there is a hard logic, and we cannot change it. So, and as an example, here we have like as erecting the walls of a house before putting up the roof. Then discretionary dependencies, they have soft logic, and these dependencies are at the discretion of the project manager or may simply change from project to project. And example is that you don't need to buy all the materials in advance at the beginning of the project. And then external dependencies, they're beyond the control of the project manager, such as having contractors sit on your critical path. Yes, so you are dependent on contractors, but you cannot change the durations. Okay, and when we're talking about dependencies, usually we want to visualize. So here we have point 0, and we can start activities A and B at the same time, and then continue further with activity D after we finish activity A, and then activity C after we finish activity B. Yes. And sometimes when we need to show that they don't affect each other, we can use dummy activity. And when we're talking about dependencies, we need to think about the slack time, which can be defined as the difference between the latest allowable date and the earliest expected date based on the nomenclature below. So, and we have TE, which is the earliest time on which an event can be expected to take place, and TL is the latest day. And the difference between the latest date on which the event can be started and minus the TE, earliest time. And now let's take a look at the network with slack time. So, as you may have understood already, where TL equals TE, this activity is on the critical path, yes? So there is no difference between late and early dates. But if TL is bigger than TE, yes, for the activity number 3, so we have a slack time of 3 days. Yes. And if you look at this chart, so we will identify the critical path, which is activity number 1, 2, 5, and 6. And we have other activities with a slack time. So if we choose path, for example, 1, 3, 5, 6, we have a slack time of 3 days for the activity number 3. Okay. So, and by understanding slack time, then the project manager can be flexible about the activities that are not on the critical path. Now let's take a look at the comparison models for a time phase PERT chart. Yes, so, and as you can see, there is always a difference between predicted and actual performance on the project. And then it is a responsibility of a project manager think what kind of actions he or she should take in order to fix and eliminate these variances. And in order to make full use of the capabilities of PERT or CPM, we could identify 4 values. Yes, the earliest time when an activity can start, ES, the earliest time when an activity can finish, EF, and then the latest time when an activity can start, LS, and finish, LF. So as you can see, there are simple formulas, but if you use them effectively, it will increase your ability to create better schedules. So when we talk about slack time, it's a good idea to put it into the table. And you can see this is like an example of PERT control output information, where you will put all the information that you are given. And then with such table, it's easier to identify slack time. And here's an example of slack identification, where we have activity C, and in the brackets you can see earliest start time and earliest finish time, and then activity time is 2 days. And we'll talk more about the forward pass and backward pass later. Yes, so at the top you can see earliest start time, earliest finish time, and below the line you can see latest finish time and latest start time, but the duration will be 2 days and it won't change. So, and a typical PERT chart with slack times, yes, where you can find various activities with the duration, and then earliest start time, earliest finish time, and latest start time and latest finish time. And then by looking at this diagram, you can schedule better and then compare the actual execution with the planned baseline. So sometimes you might have a negative slack, which usually occurs when the forward pass extends beyond the customer's end date. However, the backward pass is still measured from the customer's completion date, thus creating negative slack. So this is most likely to result when the original plan was highly optimistic but unrealistic, and the customer's end date was unrealistic. One or more activities slipped during project execution, which is often the case. Then the assigned resources did not possess the correct skill levels. The required resources would not be available until a later date. Okay, now let's take a look at the slack time. So first we are doing the forward pass. We have a customer's start date, and then we calculate all the activities, and when we sum all the activities on the critical path, we will get the duration of the project. And then we are doing the backward pass. from the customer's finish date. And then by doing so, we can better understand whether our schedule is realistic or not. So, and when we are talking about slack time, we can use another name, which is maximum float. And the equation for maximum float is latest finish plus earliest start minus duration. And by doing so, we can calculate our maximum slack time. And when you're working on the project, then you need to think about what kind of replanning techniques you might use. So there are two main techniques, which are resource leveling and resource allocation. So resource leveling is an attempt to eliminate the manpower peaks and valleys by smoothing out the period-to-period resource requirements. Yes, but that's not always the case because it depends on the project itself. So the ideal situation is to do this without changing the end date. However, in reality, the end date moves out and additional costs are incurred. Then resource allocation, also called resource limited planning, is an attempt to find the shortest possible critical path based upon the available or fixed resources. And the problem with this approach is that the employees may not be qualified technically to perform on more than one activity in a network. And also they might not have time or can be overutilized. So this is the end of today's lecture on planning. And here's the reference for this lecture. Thank you for your attention and have a good day.